in order to solve it. It's just amazing how long computers take to reboot anymore.
Yeah.
Makes me think that 20 years into the future, it'll take an hour and a half to reboot a computer.
Yeah.
Because I know 20 years ago it didn't take 8 minutes to reboot, and now it does. Just so many processes running that takes a long time. All right, I got these two documents. You want to just go through them one by one, or you have a specific one you want to look at?
No, I have something to say about these. These are for the test tomorrow, and she said this right here was a quiz she gave to BC students, so that's advanced for me. And she said most of them failed it, so this is supposed to be really hard, she said.
Well, it didn't look so hard when I first looked at it. I don't know. Let's take a look at it. Water flows into the tank at, that's a rate, so that is a derivative. If the tank holds 32 gallons when T is 2, how much water in gallons was in the tank when T is 1? Well, first of all, how much water goes into the tank? It's integral as net change. So what information did they give us?
It starts at 32 gallons.
Well, not really starts at. In other words, they don't really tell us what it started at. I'm assuming that it started at 0, since they don't say anything about it. But they say that it held 32 gallons when T is 2. Well, if I were to integrate this function from 0 to 2, that has to equal 32. So how much water in gallons was in the tank when T was 1? All right, now I'm confused because I don't understand why the answer is not the integral of this from 0 to 1. And if that were the answer, why would they tell us that it held 32 gallons when T is 2? Could this be, hold on a moment, T is between 0 and 2, T in minutes. Well, what do we get if we do 0 to 1 of this thing? We get 6t cubed, so we get 2t cubed plus t, evaluated from 0 to 2. What does that equal? Let's see, that's 16 plus 2, which is only 18. So the tank must have had 14 gallons in it to start. All right, now I get it.
Just 32 minus 18.
Well, we know that in 2 minutes, 18 gallons flowed into the tank. And if the tank had 32 gallons at 2 minutes, it must have started with 14 gallons. So to figure out how much it had in the beginning, or at 1 minute, it's going to be that. So if we evaluate this thing at 1, we get 2 plus 1, or 3. So in the first minute, only 3 gallons flowed in, so 17. Yeah. Is that what you said?
Yeah.
Okay. Do we have answers on these?
I'm having her send them to me.
All right, as long as you know whether I'm doing it right or not. Incidentally, I picked up an AP Calculus test book, Kaplan's, from the library, and I have taken a picture of the tests, and I have 3 AP Calc tests digitized in my computer now.
Oh, nice.
Yeah, it'll come in handy. I have a number of calc students that are going to be preparing for that. So the only thing I would ask you that if you get your own review material, don't get Kaplan's if you have a choice. If you have a choice between Kaplan's and Princeton Review, get Princeton Review. Because whenever we review for it, we'll be accessing these Kaplan tests, and it's better if you haven't seen them already.
Yes.
You know what I'm saying? Okay.
Mm-hmm.
All right. So a particle travels on the x-axis, meaning it goes like that, with a velocity function of that. If the particle is at x equal 1 when t is 0, then its position when t is pi is going to be 1 plus what?
1 plus...
Plus the displacement between 0 and pi, right?
Yeah.
You got 2 things when a particle is moving on the x-axis. You got displacement, which is the total net change. In other words, if I'm moving on the x-axis and I start at x equal 1, and I go that way, and then I go that way, and then I come back to there, I've got no net change.
Mm-hmm.
But my distance, which is a different thing, is quite a bit. It's a lot different than the displacement. So when they want to know where the particle ends up, you're talking displacement, not total distance. So we would do the total displacement from 0 to pi of that function. And this is a non-calculator. So let's do this. How do you evaluate that?
Now we got to take the antiderivative. So if we would pull a 6 out, it would be cosine of t over 2 over t over 2. No, it would be cosine of 1/2 t over t. I don't know what I'm trying to say.
Okay. First of all, I didn't put my parentheses in, which I should have. When you take the antiderivative of a trig function, in other words, let's say we want to take the antiderivative of 5x. That is minus cosine of 5x divided by 5. Okay? So here I'm taking the antiderivative of 1/2 x, basically. So it's going to be minus cosine of t over 2 divided by 1/2 or multiplied by 2. So it is minus 2 cosine of t over 2 evaluated from 0 to pi.
Alright, so cosine of pi over 2 would be 0, so then that entire thing would only equal 1, and then minus cosine of 0 is 1, so it would be negative 2 times 1 is negative 2 times 6 is negative 12, plus 1 is negative 11.
So we had 1 plus
11.
0 minus 12. Yeah, so we got minus 11, right? Did I do that right?
Right.
No, hold on. Maybe I didn't do that right. No, I think we got a double negative here, don't we? Let's see. When we plug in 0, we get minus 12, but
then let's add 1.
it's a minus 12, is it not? In other words,
Yeah,
isn't it this? It's when we plug in pi. In other words, let's just evaluate this. Let's set aside the 1.
you can do that?
Yep, because that was its starting position. The net accumulation or the net displacement is this amount here.
Okay. Yeah, I added that 1.
So when I plug in pi, I get 0. Minus, when I plug in 0, I get minus 12.
Okay.
So it's 13. Should be the answer. Is that one of the choices? Yeah, E. Is that right?
I can only assume until I get the answers.
What's that?
I can only assume until I actually get the answers from them.
Oh, okay. All right. So we'll just go on. See, these are very straightforward. I was actually kind of surprised. I took a look at the AP Calc AB test, a sample test, and it's not bad. It starts out pretty simple. I was kind of surprised. I had never seen a book before that had practice AP Calc exams in it. I think this is relatively new. I've been looking in the library for many years. Yeah, this book I'm looking at is 2013, 2014. I don't think they've been around that much before in the past. So the area between these graphs is what?
We would do area between the graphs. I'd have to graph it. Let's see.
Okay, let's go ahead and graph it. There's the x cubed, y equal 4x. In fact, that looks right out of my book. I'm not kidding you. I saw this shape. Yeah, when I was taking the pictures today and putting it into my computer, I saw this exact shape. I'm wondering if wouldn't surprise me at all if your teacher is already pulling questions from the AP Calc test practice booklets.
Yeah, that'd be nice. So let's do the integral from wherever they cross, we have to set them equal to each other.
Okay. So we said x cubed equal 4x. What are the two solutions?
Plus or minus the cube root of 4x.
So what is this intersection point?
Cube root of 4x.
No. Let's solve this for x. The proper way to solve it is not to divide both sides by x because you lose the 0 solution. And we can see that there's a 0 solution right there.
Yeah.
To do it right, you subtract 4x from both sides. Then you factor out the x.
That should be 2.
So there's one solution, and then the other solution is plus or minus 2, because if I continue that thing down, it also does that. So the area between the graphs is
the integral of negative 2, 0.
Well, now hold on a moment. Hold on. Let me draw this thing a little bit better. Now, they didn't specify first quadrant. in this question. In other words, they didn't say just that area. If I'm looking at these two curves, the area between the two graphs is both of those, right?
Mm-hmm.
So what's the answer got to be?
That would be 0.
Well, it's 0 if this is considered a net negative area, but I'm not sure that it is. It actually would be 2 of these. I'm pretty sure the answer is going to be 2 times from 0 to 2, 4x minus x cubed dx. Because when they say the area, they kind of mean absolute value, I think. In other words, that's a little different than if I gave you a curve like this and I said, what's the area between the sine wave and the x-axis? That's clearly 0, because this is considered negative area. But the way this question is worded, we better be careful. We might want to check multiple answers here just to see. So let's assume this is correct, and let's do it and see if that answer's on there, and maybe check and see. I saw that the 0 answer is on there. So 0 is certainly a possible answer, but let's see what this other one is. In other words, let's figure out what twice this area is, because it is definitely symmetrical with the origin.
Mm-hmm.
So do this.
So the 2x squared minus 1/4 x fourth. Do the 2, and that would be 8 minus 4. So just be, your total time would be 8?
Yeah. The total absolute area would be 8. Naturally, they have 8 on there, and they also have 0. It's going to be one of those two, depending on what they mean precisely. I suppose it could even be 4, because maybe they're referring to this area only. Although they did not say it was bounded by the y-axis. Mm-hmm. They just said the area between those two curves, and that actually includes this area down here also, does it not? I mean, I would think it would.
Yeah.
What's the answer? Oh, you don't have the answers yet.
Yeah, I'll keep checking on that.
Yeah, we'll have to go on. Just that's, to me, that's a bit of an ambiguous question, which surprises me a little bit. Or else I'm just not interpreting it the way that you're supposed to, which could be the case also. As long as we understand how to do it, if we know what they mean. That's the important part. Okay, the area between the curve, that's the absolute value function. And the line 2y minus x minus 3, which is y equals x over 2 plus 3 over 2. So it has an intercept at 3/2 and a slope of 1/2. Well, at least here the area is all positive. We're looking at this area right here.
Mm-hmm.
So how are we going to do this because it's an absolute value? How do you integrate the absolute value function?
Doesn't it like be plus or minus?
You break it up into two parts. In other words, you go from that intersection point to 0 using minus x, and you go from this point to this point using plus x.
All right.
Okay. So first of all, where do these intersect? So that's equal to, when that's equal to minus x, I've got minus 2x equal x plus 3, minus 3x equal 3, x equal minus 1. So that point's minus 1. And when I set it equal to positive x, everything to the right of the y-axis, then I got 2x equal x plus 3, x equal 3. So that's the way you got to handle, unless you're doing it in a calculator, and then you can actually put in the absolute value of x, and it would do it all in one step. But if you're doing it without a calculator, there's really two different functions here. And you can consider that's a cusp anyway. We can't really integrate at a cusp. We would have to do it in 2 steps maybe anyway. I'm not sure about that actually. If you were allowed to use a calculator, could you do this all in 1 step using the absolute value function? Possibly, although corners, you can't differentiate around corners. I'm trying to think if you can integrate. Gosh, I'm not positive. But anyway, the answer is going to be minus 1 to 0 of what?
X over 2 plus 3 halves, and then minus the absolute value of x. And then plus
minus the x function, which is minus x. In other words, this function, that function right there is y equal minus x. This part of the function is y equal x. Okay, so I'm breaking it up into 2 functions instead of using the absolute value. And this area right here is the straight line function minus a minus x. And then I'm going to add to that the area from 0 to 3 of x over 2 minus 3 halves minus a positive x. So that's the way I want to do this. Let's blow it up and see what we get. Let's do this one first, over here on the right. So first of all, let's simplify that. We got x over 2 minus 3 halves plus x. So that's 3x over 2 minus 3 halves. I can actually factor the 3 halves out so that I have 3 halves times x minus 1 dx from minus 1 to 0. Do you see how I did each step there?
A little lost in the last one.
Okay. First of all, I added that and that to get 3 halves x. And then I just factored the 3 halves out. Leaving, in other words, I went 3 halves times x minus 1.
Okay.
The only reason I did it is because now I take the 3 halves out of the integral, and this makes everything a little bit simpler, I think.
Yep.
So we evaluate this. We got x squared over 2 minus x from minus 1 to 0. Well, the 0 part is clearly 0 minus the 1 part. Now, the biggest problem with evaluating integrals, to me, the easiest mistake to make is the negative signs that you're dealing with and parentheses. Use extra parentheses just so you don't make a mistake, I think. In other words, because otherwise you can really get screwed up here. When I plug in minus 1, I got 1/2 minus a minus 1. See what I'm saying, all the negative signs? Okay, Okay, so this is 3 halves, so 0 minus 3 halves. Ah. How can that be a negative area? What did I do wrong? Hold on a second. Okay, y is equal to x plus 3. It was plus 3, not minus 3. See this equation right there? When I solve that for y, I get x plus 3 divided by 2. So this should be a plus. That should be a plus. That's going to make that a plus. And that is. Now, when I plug in 0, I get 0 minus, when I plug in a minus 1, that's a plus. So now it's a negative half, but it's negative a half, so that whole thing is equal to a half. So this area right here is equal to 1/2. You with me?
Mm-hmm.
It was a good lesson to be learned from that. That is, I came up with a negative number and it was impossible. I'm looking at the graph, I can see that it's above the x-axis. Okay, so now the second part of that is going from 0 to 3. So that is 3 halves 0 to 3 of x plus 1. Sorry, could have just used the same thing. And this is going to be 8 halves plus 3, 7.
Maybe 9.
Well, I get 7. How do you get 9? I get...
Alright, want to be 9 halves and plug in a 3?
Yes. Excuse me. 9 halves plus 3, that's 7.5. 7.5 plus a half is 8. That answer on there? Ah.
No.
Oh, did I multiply everything by 3 halves? I did not. I didn't multiply the first one by 3 halves, which made it 3 fourths. And I got to multiply the second one by 3 halves, which I forgot to do. I'm multiplying 15 halves by 3 halves, so that's 45 fourths. 48 fourths is our answer. 12.
No. It was long.
We decided that this was plus. Oh, hold on. Here's where I made my mistake. When I integrate this, I get plus x, so I have 3 halves x. But when I integrate this one, I get minus x. So I have minus x over 2, or minus, yeah, okay, let's do the second part again. I didn't do the second part correct.
Okay.
Sorry. This is actually a pretty good problem because it demonstrates how to use absolute value, and it also demonstrates how easy it is to get your signs mixed up.
Right.
So my other equation is x plus 3 over 2, correct?
Mm-hmm.
So this is x plus 3 over 2 minus x. And that is minus x over 2 plus 3 halves dx. Let's just go ahead and integrate it without taking the half out. So that's minus 1/2 x squared divided by 2 plus 3 halves x. And I'm going to evaluate it from 0 to 3. Well, at 3, it is minus 9/4 plus 9 halves. And at 0, it's obviously 0. So this is 18/4. So that's 9/4 is the area of the right part. What we get on the left, 2/4. So 2/4 plus 9/4. I don't think 11/4 is on there either.
Was it 2/4? I thought it was 3/4 maybe.
Oh, you're right.
No.
It was. No.
Well,
hold on. Let's see. No, the first one I thought was 1/2. And I think I did it correctly. Oh, no, because I forgot to multiply by 3 halves. So you're right. The first one was 3/4.
So it's 12/4 and it's 3. And that's an answer.
3 is an answer?
Yeah.
Thank goodness. My goodness. I never had so much problem with arithmetic before. Well, like I said, make sure you keep track of your signs and your parentheses and other stuff that I didn't keep very good track of. Okay. X equal y squared, I believe, is that. And y equal x minus 2 is something like that. So they want this whole area. Now this is going to have a positive and a negative, so let's think about this for a moment.
Do we take off it? Because that's like the same question that we did. That's just the area between the two. Do we have to subtract that?
What's the best way to do this? Is to put vertical rectangles or horizontal rectangles in there?
Looks like vertical.
Well, I got a problem with vertical rectangles.
I mean horizontal.
What's the height of that vertical rectangle?
I don't know.
And I could do it, but, I mean, there is a way to do it, but I think this problem is made for horizontal rectangles because
right minus left.
We should be able to go from this point to this point using the function described as a function of y. In other words, we have x equal y squared. That's already described as a function of y. And the other one's going to be x equal y plus 2.
Will it go to where they intersect, or will it go to the almost left?
Yeah, we want to where it intersects. In other words, this point here, the y-coordinate of that point to the y-coordinate of that point. Well, where do they intersect? Y squared equals y plus 2. That's y squared minus y minus 2 equals 0. That's y minus 2 times y plus 1 equals 0. So they intersect at minus 1 and 2. So we should be able to do it all in one step. What's the function that I'm going to subtract? Which function am I going to subtract from the other one?
I'm going to do right minus left, so y plus 2 minus y squared.
And this might look like a corner or a cusp, but it's not. It's smooth. So let's see. Now, the way I would do this, just to make sure that I've got everything correct, so I'm going to put that minus this. We got lots of pluses and minuses inside. So what do we got here? We got 4 over 2 plus 4 minus 8/3. This side we got 1/2 minus 2 plus 1/3. When we plug in minus 1, this stays minus 1/3. Minus a minus becomes a plus. So what do we have now? We have 6 minus 8/3. So that's 18/3 minus 8/3. So that's 10/3 minus, and over here we have 3/6 and 2/6. So 5/6 minus 12/6. That's minus 7/6. So we have 20/6 plus 7/6. 27/6. Which is the same as 9/2.
Yes. I was looking at this, I was like, crap.
Both divisible by 3, but okay. Cool. See, these really aren't that hard. These are actually, I think, a little easier than the ones we worked on over most of the last week.
I think they're easier. At the number 4 was definitely way more steps than we're used to doing now.
Yeah.
In our level.
Well, yeah, and we were covering absolute values this time, which we hadn't covered before. So.
Like, we know how to do it, but we would not necessarily have that many steps.
Yeah. A solid has a base, the inside of an ellipse. You know how to graph that ellipse?
No.
Well, what's the general format of an ellipse? Oh, hold on, maybe we don't need to do that. We may not need to graph it. Well, here's the general format of an ellipse. You probably should know it even if you don't. But it's, if it's at the origin, which this is, it's x squared over a squared plus y squared over b squared equals 1. So since I have this equal to 36, I have to divide both sides of the equation by 36, which gives me x squared over 9 plus y squared over 4 equals 1. That's the equation they've given us. Which makes a equal 3 and b equal 2. So now, if I want to draw the ellipse, I know that from there to that vertex is 3, and from there to that vertex is 2.
All right.
Okay, so we're going to put isosceles right triangles perpendicular to the x-axis. Every single one of your cross-sections has been perpendicular to the x-axis. So there's one of the isosceles triangles. What's the length of that base?
I'm going to do top minus bottom, so do the positive half minus the negative half, so then just be the original
So if I take this equation and solve it for y, in other words, the base is 2y, right?
Oh, yeah.
Well, here, let me do it first. We have 9y squared equals 36 minus 4x squared. So y squared equals that divided by 9, and y equals plus or minus the square root of that. And we're going to take the plus side, which would be the distance from here to there, and that's going to be half our base. So our base is going to be 2 times this. Okay. We have a right isosceles triangle, where that's the right angle. So if that is our base, in order to figure out the area, we need our height. What's the height equal to relative to the base?
I'm not sure. We haven't done many of these.
Well, let's think for a moment. If that's a right isosceles triangle, these are each 45. So that's a 40. So that'd be this side is equal to this side, but the height is, if I draw my similar triangle here, 45, 45, it's 1, 1, square root of 2. And in this case, that's 1/2 the base. So this would be square root of 2 over 2 times the base.
So then it's that over 2.
Well, it's that times square root of 2 over 2. Well, let's first of all, here, let's, the area of each triangle. It's 1/2 the base times the height. So we have 1/2 of this, we'll just call it the base rather than have me completely rewrite it. This is the base. And the height is square root of 2 divided by 2 times the base. And that's going to make it easier, because notice that we have the base squared, which is going to get rid of this radical sign, which is good because that was going to be a hard thing to integrate. So we can just multiply those two numbers together and have b squared. So the area of each triangle should be root 2 over 4 b squared, which is, boy, it started out easy, but it's getting complicated quick.
Yeah.
Worst part is if I don't come up with the right answer, I'm not going to know where I made my mistake because there's so many steps. Let's see. So the area is equal to root 2 over 4 times that whole thing squared, which is 4, squaring the 2 part, and then everything else is without the radical sign. So that's the area of each triangle times dx. I'm going to integrate from -3 to 3. Well, let's simplify this thing. And we know it's symmetrical, So I can integrate from 0 to 3 and multiply it by 2. So let's cancel that 4 and that 4. Let's take this root 2 outside. So we have 2 root 2 times the integral from 0 to 3 of 36 over 9, which is 4 minus 4x squared over 9 dx. So this should be our answer. What is this? Let's not forget to multiply by that. 4x minus 4x cubed over 27 evaluated from 0 to 3. 2 root 2 times 12 minus 4, which is 8. 16 root 2. I don't see nothing that looks like that.
There's 16.
I think I messed up on finding the height, although actually that sounds right. What am I off by? A factor of... That root 2 might be the thing that I'm wrong on. Let's see. If I take that 45-45 triangle, no. If this is the base, oh no, hold it. The way I'm looking at it, this is the base, right? And I'm trying to find this measurement. So, if I take one of these triangles, that half triangle right there, it's also a 45-45, only that's half the base. And I'm wanting to find this measurement here. So that would be half the base also. Yeah. So it's not root 2 over 2. When I go back to my area, it's just the base. It's 1/2 the base times the height is 1/2 the base. So it would be 1/4, not root 2 over 4 times b squared. That takes care of my routine, so 16 is the answer. Because I had a root 2 in there that shouldn't have been in there. And if I take my root 2 out, then my answer is 2 times 8, or 16.
Okay.
Wow. I only had a half a glass of wine for dinner, I swear. But I had problems with the arithmetic tonight. But there's a lot of arithmetic. It's easy to make a mistake. It's almost unfortunate that the answers aren't the integrals set up. Although the mistakes you make in arithmetic, I didn't make evaluating the integrals. I made it setting them up. Just trying to figure out what the area of that triangle was is a little difficult. But anyway, hopefully that's helped. So did you have your quiz? You had a quiz yesterday, didn't you?
Yeah, it was part of the test. I think I did good, except for there was one part that I haven't really seen before was like find the line tangent to another point on the same. I don't know. I did good on 3 out of the 4 parts, so
When
I did good.
when they ask you questions, define the equation of a line tangent. It's all about slope. You need to find the slope of that line, and slope is the first derivative.
Yeah, I started off by taking the first derivative, but then just what it wanted. I don't know, it was weird. It wanted me to take the derivative, and it was like to find half of the area of the line. I don't know, I didn't know how to do it.
All right. All right, well, good luck on your quiz tomorrow.
All right.
All right, talk to you later, Matthew.
Thanks. All right, bye.
Bye-bye.